For decades, science fiction has imagined mysterious signals traveling between galaxies, secret messages crossing interstellar space, and distant civilizations communicating through powerful beams. But the real story of Andromeda is already extraordinary enough without any fictional transmissions. Known to astronomers as Messier 31, or M31, the Andromeda Galaxy is our nearest large galactic neighbor. It lies approximately 2.5 million light-years from Earth and contains hundreds of billions of stars, with estimates varying depending on how its enormous stellar population is counted. On a clear, exceptionally dark night, Andromeda can even be seen without a telescope as a faint, hazy patch of light. But that peaceful appearance is deceptive. Andromeda is a vast, dynamic system shaped by gravity, stellar evolution, dark matter, and a history of interactions with smaller galaxies. Astronomers have discovered enormous streams of stars surrounding M31. These structures are believed to be remnants of smaller galaxies and star systems that were disrupted by Andromeda's gravitational influence. Instead of imagining a galaxy as a permanent collection of stars, it is better to think of it as a constantly evolving ecosystem. Galaxies grow by accumulating gas, forming stars, and interacting with neighboring systems. Andromeda provides an unusually valuable example because it is close enough for astronomers to study individual stars and stellar populations in remarkable detail. Modern surveys have allowed researchers to map large portions of its enormous halo. The distribution and motion of stars reveal clues about the galaxy's past. Some stars appear to follow unusual trajectories, while others are arranged into long, faint streams stretching across huge distances. These structures can survive for millions or even billions of years, preserving evidence of ancient gravitational encounters. This process is sometimes described as galactic cannibalism. The term sounds dramatic, but the physics is straightforward. When a large galaxy encounters a smaller galaxy, the larger system's gravity can gradually pull material away from its companion. Stars may become scattered into extended streams, while gas can be compressed or redistributed. Over time, much of the smaller galaxy's material can become incorporated into the larger system. Andromeda appears to have experienced several such interactions throughout its history. Its central region is also dominated by a supermassive black hole, surrounded by enormous concentrations of stars. However, the black hole is not controlling the entire galaxy like a cosmic vacuum cleaner. Its influence is strongest near the galactic center, while the structure of the wider galaxy is governed by the combined effects of gravity from stars, gas, and especially dark matter. This hidden component is one of the greatest mysteries in modern astronomy. Dark matter does not emit or reflect light in the ordinary way, yet its gravitational influence helps explain the motions of galaxies. By studying how stars and satellite galaxies move around Andromeda, astronomers can estimate the distribution of unseen mass surrounding it. This makes M31 more than just a beautiful object in the night sky. It is a natural laboratory for studying how galaxies form and evolve. And there is another reason Andromeda matters so much to us. It is not simply a distant neighbor. It is part of our own future. The Milky Way and Andromeda are moving toward one another under their mutual gravitational attraction. Astronomers expect the two galaxies to interact in the distant future, although the exact timing and final outcome remain subjects of ongoing research. This does not mean Earth is facing an imminent disaster. The distances between stars are so enormous that direct stellar collisions during a galactic merger are expected to be extremely rare. Instead, gravity will gradually reshape both galaxies. And that is where the real cosmic drama begins. Imagine looking into the night sky millions or billions of years from now. The familiar shape of the Milky Way would no longer look the same. One of the most important reasons is our neighboring galaxy, Andromeda. The Milky Way and Andromeda are among the dominant galaxies in the Local Group, a gravitationally bound collection containing dozens of galaxies and many smaller satellite systems. Their enormous dark matter halos extend far beyond the regions visible in ordinary photographs. As these halos interact, gravity gradually changes the trajectories of both galaxies. For many years, astronomers described the future encounter between the Milky Way and Andromeda as an almost certain collision. Modern observations have produced a more nuanced picture. The galaxies are moving toward one another, but their exact future trajectory depends on several factors, including their current motion, the gravitational influence of other galaxies, and the distribution of unseen dark matter. The encounter, if it proceeds as expected, will unfold over an extraordinary period of time. This is not an explosion. It is a gravitational transformation lasting hundreds of millions or even billions of years. As the galaxies approach, their enormous gravitational fields will begin disturbing their spiral structures. The elegant arms of both systems could become stretched and distorted. Gas clouds may collide and become compressed. That compression could trigger periods of increased star formation. Some stars could be thrown into new orbits, while others could move toward the outer regions of the resulting system. Yet the idea that stars will smash directly into one another is misleading. A galaxy contains an enormous number of stars, but the space between them is even more enormous. The Sun, for example, is separated from the nearest neighboring star by more than 4 light-years. During a galactic merger, individual stars generally pass through the system without directly colliding. The major changes are gravitational. Eventually, after repeated interactions, the two galaxies could settle into a larger combined galaxy. Astronomers sometimes use the informal name, Milkdromeda, for the possible future system. Its final appearance could be very different from either galaxy we see today. The familiar spiral structures may disappear, replaced by a larger, more rounded stellar distribution. Our own solar system could experience changes in its galactic orbit, although the probability of the Sun directly interacting with another star would remain extremely small. There is another fascinating possibility. The Sun itself will not remain unchanged throughout this immense period. Long before any final stage of a Milky Way-Andromeda merger, the Sun will naturally evolve as it ages. Therefore, the distant future of Earth is determined by both stellar evolution and galactic dynamics. Studying Andromeda helps astronomers understand these processes today. By mapping its stars, gas, satellite galaxies, and dark matter environment, researchers can compare observations with computer simulations of galaxy formation. These simulations allow scientists to reconstruct possible histories and explore how galaxies transform through repeated gravitational encounters. Andromeda also teaches us something fundamental about the universe. Galaxies are not isolated islands. They exist within enormous networks of gravitational relationships. They grow by consuming gas, forming stars, interacting with neighbors, and sometimes merging with other galaxies. The Milky Way itself contains evidence of ancient mergers. Streams of stars in our own galactic halo reveal that smaller systems have been absorbed into our galaxy over cosmic time. So when we look at Andromeda, we are not simply looking at another galaxy. We are seeing a possible preview of our own galaxy's distant evolution. There are no confirmed alien warnings coming from M31. There is no verified evidence of artificial laser networks or mysterious communications from Andromeda. The real story is more fascinating because it is supported by observations. A galaxy 2.5 million light-years away is carrying evidence of ancient collisions, invisible dark matter, stellar evolution, and a possible future encounter with our own cosmic home. Andromeda is not a threat approaching Earth. It is a reminder that the universe is constantly changing. The same gravity that keeps stars moving around galaxies today will eventually reshape entire galaxies tomorrow. And somewhere in that distant future, the Milky Way and Andromeda may become part of one enormous new cosmic structure. Another chapter in the never-ending evolution of the universe.